Hello everyone. Our lecture for today will be working on some examples and exercises. We tried the blackboard, but we have an issue, so we'll solve some examples and some exercises. The first example we'll go over is in page page 67. Okay, so page 67 in your textbook, you have example right here. The example is for the half wave. Okay, page 67. So we have a half wave. It's a half wave rectifier, guys. Okay, uncontrolled, and the V source is 120 RMS. And the frequency is 60 Hertz and the load is 5 ohms. The question is determine the following, which is the average load current. What they mean by that? They mean V out DC. They want you to find V out DC. Then the average power absorbed by the load. When they say absorbed, you put in your mind that they're looking for V RMS, but here they said by the load, means V out RMS. They're looking for V out RMS and the power factor. You know the power factor, okay? That's what they're looking for, guys. So they're looking for V out DC, and they're looking for V out RMS, and they're looking for the power factor, okay? Let's see what we have here. Of course, as I told you before, guys, in your notes that all equations are right here. So for example, if you're looking for half wave and you want to see your equations, okay, so the equations for the half wave in your notes listed here, you will have them, you can see them in the book, but you can look at this table right here, which is in page 11, and this is V out DC. Those equations are for the half wave with resistive load only, okay? If you have inductive load, they will be the same, except the V out DC, as I told you last time, it will be this equation, which is in page 12, V out DC, V max over 2 pi, 1 minus cosine beta. We have this equation changed because we have a negative ripple, okay? We're not gonna derive equations, because we don't have time for deriving. Anyhow, those are the equations, and this is the example right here, page 67. So let's answer the part A, which is average load current. So it means they're looking for V out RMS, V out DC. That's A, they're looking for V out DC. So we know from this here, or even from textbook, if you want to look at it in textbook, that V out equals V max over pi. V max over pi. You can find those equations in page 66. So V out equals, okay, as I told you right here, you can find them in the notes or in your textbook. In the textbook it says here V max over pi. V max over pi. Okay? I have the value of pi, which is 314, but I need to find V max. I need to find V max. Okay? You can find V max from here, from those equations right here. Okay, which is so let me just tell you what will be the equations for V max. We have V RMS equals, those are the equations, V RMS, okay? That's for the source, V RMS source equals V max over square root of 2. That's for the source, okay? And V out RMS this is V source, and V out RMS, okay, equals V max over 2. Okay? This is for the V out RMS, and this is for the V source. Okay, you can find them in the table, or you can find them right here. This is on page 66. Okay. So now let's find V max. So I can, since this is the source, I will use this. So it will be, I'm looking for V max. I want to find V max, so to replace. So it will be this one here. It will be V max equals V source RMS times square root of 2. So V max equals, this is given, which is 120, times square root of 2. Okay? Equals, you can do the multiplication, and then just leave it like this, no problem. Just leave it like this. Just now you can find V out. So V out equals this 120 times square root of 2, okay, divided by resistance. That's V max. Okay, so this is V out, and V max. Okay, so V out will be V max divided by pi. Okay, yes, V max divided by pi. Okay, so you can take this value, okay? You can take this value. I don't have a calculator right here, so I can do it. Or you can do it right there. So you can take this value right here, which is 120 times square root of 2 divided by pi. That's V out. Okay? So they're looking for the load current. Here, they're looking for the load current. Sorry, I told you V out DC. No. They're looking for the load current, which is I out DC. I out DC. I'm so sorry, guys. I out DC, okay? Means we're not done yet. We need I out DC, so I out DC equals Ohm's law, V out DC divided by the resistance, okay? So you're gonna take this value right here, this value right here, I don't know how much is it, divided by resistance. You're going to take all this value right here, okay? You will divide by the resistance, which is 5 ohm, okay? So you will take this value right here, okay? You can use another color right here. So I can take this value right here, which is by pi, okay? Put it right here, and divide it by 5, okay? So the results or the answer will be 10.8 ampere. Okay? 10.8 ampere. This is part A. Or I can leave it here so I can have space for B. Okay? So this equals 10.8 ampere. That's your answer. Okay? Let's look here for C or B. That's B right here. B, it says average power absorbed by the load. So since you see the word absorbed, it means V out RMS. So average power absorbed. Average power absorbed by the load. Since they said by the load, you know that they're looking for V out RMS. Not VRMS, V out, because they said the load. So average power absorbed by the load, and it's the power. So here, they're not looking for the V out RMS, sorry, they're looking for the power. So they're looking for the P out RMS. I don't know why it starts with those values, but anyway, it's P out RMS. Okay? So here, even before here, I started wrong. It should be, they're looking for the average load current, which is I out equals, I out DC equals V out DC over resistance, okay? And the V out DC, I out DC here, and the V out DC equals the V max over pi. And then we go from there. But this is what they're looking for, okay? I had the issue here and I carried it with me there. Anyway, now they're looking in part B for P out RMS. So now P out RMS, P out RMS. Ohm's law, guys. Same thing, you're gonna find the equation right here, okay? See here, P out RMS, I am in page 11. It's I out RMS times V out RMS, Ohm's law. So you can say here, V out RMS times I out RMS, okay? Okay, so to find the P out RMS, or the power absorbed by the load, again, you need to pay attention to this word. When they say absorbed, it means RMS. So now I have V out, do I have anything from here? All I have from here is I out DC. Do I have V out RMS? Yes. This is V out RMS. I can find it from here. From this equation. Not this equation. Before I use this equation for V source RMS, I use this because this is for the source. Now, to find V out RMS, you need to use this equation, which is V out RMS equals V max over 2. Do I have V max? Yes, I do have V max, which is this 120 times square root of 2. So this is 120 times square root of 2 divided by 2. That's V out RMS. Okay. So this is right here, it would be 84.9. 84.9 volts. That's V out RMS. Okay. Of course, you know, for the power, we have 3 equations. We have this equation, which is the main equation. Also, we have another equation called P out RMS equals V out RMS squared divided by resistance, right? V out RMS squared divided by resistance. And which equation that we have the values given? This one here, we need to find I out RMS, but here we already have everything. We have the V out RMS, which is 84.9, and we have the resistance, which is 5. So divided by 5. Okay. So 84 squared, of course, divided by 5, and that will be 1440 watts. Okay, because it's power. 1400. There is a mistake in the textbook. It says that the resistance is 4, but it's 5. Okay, so that's the average power absorbed, which is P out RMS. What we have left is the power factor, and Okay, Vmax over 2R. Okay, to calculate the IRMS, which is this, okay, I out RMS, I out RMS, okay, Vmax over 2 resistance, Vmax over 2 R. How we get that? We get this equation right here derived from this equation. From this equation right here. This equation right here is derived from this equation. This one is V out RMS equals Vmax over 2. You can find this in page 66 and you can look at it. Okay. So we know that Ohm's law, by Ohm's law, if I derive this, that I out RMS equals V out RMS divided by resistance. So if I come and take this here and replace it right here, or insert it right here, it will be what? It will be Vmax over 2 over resistance. So you know what you need to do. You flip, you put this one over 1, and you convert it to multiplication, and you flip. So I out RMS equals, it will be Vmax divided by 2R. That's how we get that equation. So we can find this. We can find I out RMS. I mean, if we want to use this equation, it will be the same. So now what's I out RMS? I out RMS equals Vmax. We know we have Vmax. How much is Vmax? Vmax, this one here, which is 120 times square root of 2 divided by, no, that's Vmax, okay, which is this, 120 times square root of 2. Divided by 2 times 5, which is 10, okay? So this case, I think it will be 17, yes, it will be 17. So this is 17 amperes, okay? That's I out RMS. So now, I can do the same, or to find the power factor. Okay, I already have this. I already have I out RMS, and I already have because you know in this case, just to let you know, guys, I out. This is a half wave. This is a half wave. Remember, the half wave will look like this, okay? And I will have power diode, and I will have load, right? Something like this. So this one is I source here. This is I source. This is I diode, and this is I out. The whole current will be the same because the connection is in series. And what's in here, it will be same as the current here, same as the current in the output. So since I have this I out RMS equals 17, means that this one also I out RMS, same as I source RMS, equals 17 ampere. Okay, so if I want to find power factor, guys, which is now C, power factor, okay. We know that power factor equals P over S. P over S. Okay? P over S. P is the, from machines, P is the real power, okay, which is the absorbed. And this one here, S, is the apparent power. It's all the power, okay? So we can say here that power factor P is, we already got that one here, which is the P out RMS, because it's the real power, absorbed real power. So this one here is real power, okay? And this one here is the apparent power, okay? So this one is already known, 1440 watt. And the apparent power is VRMS, V source, RMS times I source, RMS. We agreed that this one here, 17, is I out RMS equals I source RMS. So we know I source. Also we know V source RMS, which is 120. It's given. So now equals here, so power factor equals 1440 watt divided by 120 times 17. Okay? So the power factor is 0.707. Okay? This is our power factor. Okay, this example right here is in page 67. Let's look at it again, please. What I want you to do, guys, to practice, there's some examples in your textbook, I mean in your notes. So please, in page 35, please look at exercise or question. I'm just put the question as it says here. Question 1. Okay. Page 35. Notes. Your notes. Okay? This is your homework, guys. This is one of your homeworks. I want you to do this example for a half wave, which is this example right here. I don't want to show you. By the way, that you will find out that there's a little mistake. The answers are given to you here, but I want you to show me the work. Okay? I want you to show me the work, and I want you to tell me if there's what will be the mistake. Okay? This question right here is, let's look at another question, which is question 3. Okay. So question 3 right here, I will erase this. Okay. Looking for V out, RMS, I out, RMS. Turn at the following. Okay, I'll erase this here. Well, the green is hard to erase. Okay, so now this is not in your textbook. Okay, and this is here. And that will be not half wave. It will be full wave now. I'm going to do example for full wave. And I don't know what will be the values now, the new values. Okay. Let's erase this. Turn the following. Get this here. Okay, so I have question 3. Question 3, your notes. Page 36. Okay. The information for that question is from question number one. Okay, information or values from question one. So it's full wave, guys. Full wave rectifier uncontrolled. The frequency again is 60 hertz. Okay, and AC source. So now it's V source here, 110 ampere. V source 110 ampere. It doesn't say V source RMS. It says V source. So you need to pay attention to those. And resistive load equals 25 ohm. Okay. Those are the values determined the following. So it says A, I think we have some more questions now. A, the average value of the output voltage, So they're looking for V out DC. B, they're looking for I out DC. C, the RMS value of the output voltage. So they're looking for V out RMS. D, the RMS value of the output current. So they're looking for I out RMS. And E, they're looking for power average delivered. So they're looking for P out DC. Okay? We'll go up to that point, up to E. That would be enough. Okay? So we will see here. And we do, we're gonna erase everything right here. Okay, let's look at A. So A, looking for V out DC. You need to know that it's full wave. So now we're going to look at the equations for full wave. So those equations are on page in page 21, okay? Equations. On page 21 notes. Okay? So V out here, V out, DC, it's 2 V max over pi. So now, to find this, V out DC equals 2 V max over pi. Do I have V max? Then I have, I have the value of which is 2, I have the pi, I need to find V max. That's the point, that's the thing that I don't have. So what's V max? What's V max? Okay, it will be that's 110 V source. Okay, and as I told you that we have 2 equations for RMS. They are the V out RMS and the V source RMS. So I have the source here. So V, if you want to find V max equals V source times square root of 2. Okay, so 110 times square root of 2, so V max will be, that's the value that I have, I think, 55. Uh, 155.61, 55.6 volt. Okay, so now V out DC equals 2 times 155.6 divided by pi. Okay, and I have 99.1 volts. Okay, which is, if the source is 110, the V out DC is 99. And that's what we noticed in our experiment in lab when we did the full wave. Our source was approximately 110. When we choose 90%, it was 110 volt, the source, and the output was 92, 93, 94. I assume you noticed that it's almost the same. The source was 110, same as what we have done in lab, which is the 90%. And the V out DC came to be here 99. There we got like 94, I think, or 95, which is almost the same. Okay, the B. They're looking for I out DC. I out DC. Okay. And for the I out DC, Ohm's law, we're going to use Ohm's law. So I out DC equals V out DC divided by the resistance. Okay? Divided by the resistance. And in this case, we have everything. We have this value, which is I out DC equals 99.1 volt divided by the resistance, which is 25 ohm. Okay, and the answer would be 3.9 ampere. 3.9 ampere. Okay, and then C, which is the V out RMS. Okay, C. Now C here, which is V out RMS. And we know the equation for V out RMS. It's V max. Yeah, you need to look at those equations as we agreed. Here, again on page 21, and the V out RMS. The V out RMS here is V max over square root of 2. Okay, so V max here, V out RMS equals V max over square root of 2. V max over square root of 2. Do we have V max? Yes, we do. Which is this. So we come here and we say V out RMS. We say V out RMS equals 155, which is this, 0.6 divided by square root of 2, and should be 110. Okay. 110. So it's the same. 110 volt. Okay. That's the V out RMS. I out RMS, which is this. You're going to use Ohm's law. So I out, which is, this is CD. I out RMS equals V out RMS divided by resistance. Just apply Ohm's law, and it will be here 110 divided by 25, and it will be 44.4 ampere. Okay. The last one is P out DC, which is E. P out DC equals I out DC times V out DC. Ohm's law. Okay. And I have the I out DC, which is this. And I have the V out DC, which is this. So just multiply this out. Okay. So here equals 3.9 ampere times 99.1, and that's 392. 392.3. Okay, watts. That's for full wave. Okay, it's in your notes, page 36. Okay, what I want you to do, guys, question number 6, that will be your homework also. That will be for three-phase half wave. So I want you to look at question number 6. Look at question number 6. Okay, page 38 in your notes. That's for three-phase half wave. You're gonna apply the same values, and you will use the equations for the half wave, which is on page 3-phase full wave, and the half wave will be in page 27. No, not in page 27, that's the multi. On page 24, okay? So you're gonna use those equations, and we already go over this equation here in theory lecture, yes, which is, I put it as a pre-lab for you guys, which is 3 represents the 3 diodes, and the square root of 3 times Vmax line to neutral, because we connect the 3-phase to neutral. That's why we have square root of 3 times Vmax line to neutral divided by 2 pi, which is 1 cycle, and the rest are Ohm's law, same as what we explained before. Okay. Okay, what I want you guys to look at also, there's example here. I will not go over it, but I will explain it to you. The freewheeling. For freewheeling, which equations are you going to use? Or which V out DC? You know the V out DC for the half wave is Vmax. For the half wave, the V out DC equals Vmax over pi. That's for the half wave with resistive load only. And with inductive, everything is the same except the Vmax will change, which is this V out equals Vmax over 2 pi times 1 minus cosine beta. In freewheeling, if you have a freewheeling, which equation are you going to use to find V out? The V out for the resistive load or the V out for the inductive? There is inductive load connected. When we did the freewheeling, there is inductive because we solved the issue. The inductive create some issues for us, which is the negative ripple, the power, goes down, and we solve those issues by adding a freewheeling diode. We improve the power, we get rid of the negative ripple and all that. But the inductive is there. So which equation you're going to use to find V out? You're going to use V out DC equals V max over pi. Okay? Or you're going to use the other one, which is the other one, as I told you, which is V max over 2 pi, 1 minus cosine beta. Okay? V max over 2 pi, 1 minus cosine beta. This is V out DC for half wave. Half wave with RL load, okay? But with resistive only, V out DC equals V max over pi. Okay, that's for R load only. So in the case of freewheeling, which equation we will be using? This equation or this equation? We're going to use this equation, guys, because we look for the output. The output will be half wave. The output, if you look at the output, it will be half wave like this. Same as the half wave, no ripple. So since we have this in the output, we're going to use this equation. So we use the equations when we have a freewheeling. We use the equations for R load only. Okay? R load only. Okay? This is just for your information. It's a very good point. And you can look at this in page 83, in example 3-7. Here it says determine the average load voltage and current and determine the power absorbed by the load. See here, it's with freewheeling, half wave rectifier with freewheeling diode. Okay? But the equation that they used is V0 equals V max over pi. Okay? Just to let you know about this. I think that will be enough for today. Just some examples that they will help you. Okay.